Hi guys, in this session I am going to explain about the parallel axis and perpendicular axis theorem. Uh, we will see that what are the theorems and what are the relationship between both the theorems. We will see some introduction of the parallel axis and perpendicular axis theorem and what are the methods for determining this, and also we will see that what are the applications in the civil engineering. So first we will see about the uh, definition. So the moment of inertia of of an area about any axis, okay, it is parallel to its centroid, is equal to the moment of inertia about the central is equal to the sum of the centroid plus the product of area into the distance square. So here this is the axis OX and YY axis, and here some rigid body is placed here, and if the centroid of this body is lying here, if I want to calculate the moment of inertia, there is a moment of inertia. So we have to first find the moment of inertia of that body. Okay, so it is depending upon the shape. So in previous session we have seen that what are the formulas, what are the ways, and what are the methods for determining the moment of inertia. By using this, we have to find the moment of inertia of the given shape, and we have to add the product of the area of that body and the distance between the two axes. Okay, so here the I is the moment of inertia about the chosen axis, and the Ig is the moment of inertia of the centroidal axis, and A is the area of the section, and D is the distance from the centroid. Okay, so this is a distance from the about y axis if I am taking this as D1, if it is a x axis if I am D2. Okay, and we will see that where we are using in the civil engineering. So this is the steel structure. So nowadays in mostly we are using the there are two types of structures we are commonly using. One is the RCC and another one is the steel. So nowadays we are using the steel structure in so many places. So in upcoming years you will study about the design of these types of structures. So here this is a structure, this is a steel structure, and here this is a plate girder I have chosen. Here the plate girders is having different components. So this is the I section, and also here this is also I section. So here they have placed different I sections are placed. So this is the built-up beams. So built-up beam means it is a combination of different shapes and different sections. So here different shapes are there, and here by using either there are three types of joinings are that either by using rivet and or also welding or bolting we can connect these different shapes. Okay, so here while we were designing or while we were analyzing these types of things, first we have to understand the we have to know that moment of inertia of the given section. So here whenever you are when you are studying about this structures, and if I am if I am choosing some I section, so for the selection of I section is depending upon the requirement of building, and here there is some code book is available for selecting the properties of the given sections. There is a steel tables are provided. So in that steel tables they have given that the standard they have given some standard I sections. So many, it may be a angular section or maybe a T section or any section. For all type of standard section they have given the property. So for an example, the weight, the unit weight of the section, and the mass moment of inertia about x axis and y axis and z axis, So if the radius of gyration, everything they have given. Okay, so if you want to do the if you do the analysis manually, we can choose the moment of inertia from that steel table, and you can analyze the structure. So if nowadays we are using the software for analyzing any structure, in START, the main software we are using the START. So in this chart, they have inbuilt all the properties of the sections. Okay, the only thing, if you are giving the inputs, if you are giving that size and the shape, the everything, so it will take that property from the automatically. Okay, and it will do the analysis. So that is a very important thing while we are designing or analyzing the structures by using the software, and it will reduce the time for designing. And here this is a column they have given. So this is a compression member. Whenever the load is applied like this, here this is a hinge joint, and then the load is applied like this, there will be the buckling will be happening there. Okay, so here this buckling is depending upon the shape, and in that part also the moment of inertia is playing very important role. Okay, and also here this is a thin walled boss section. In the analysis of these types of structures, and also whenever we are going for the earthquake, this is a structure, this is a frame which is they have taken, and here there may be the chances of if the structure is in the earthquake prone area, there may be the lateral loads will be at base. If it is the building at the where the wind velocity is more, it will be subjected to the lateral force, as the wind force will be a lateral force. So in that, the structural behavior will be different. Okay, so therefore here also the studying of moment of inertia is very important. And also for designing the ships for the mariners, this Parallel Axis Theorem is important. And the next one is the Perpendicular Axis Theorem. So this is the for a plane area, the moment of inertia about an x-axis perpendicular to the plane is nothing but sum of the moment of inertia about the two mutual perpendicular planes. So if I am taking this, this is a x-axis, y-axis, z-axis. If I want to find the moment of inertia about the z-axis, I have to add the moment of inertia. I have to find the moment of inertia of the given section about the x-axis and the y-axis, and I have to calculate and I have to add both the thing, and then I'll get the moment of inertia in another axis. So here these axes are it is mutually perpendicular to each other. Okay, and the next one is where we are using this perpendicular axis theorem. So this is also used for designing the structural shapes and designing of the beams and columns, and analysis the slabs and plates, and also the torsion analysis of the circular members, and structural connections. So the connections and joints we are using nowadays, we are using the bolt and welds. So if it is the height of the structure is large, we are going for the bolting. So whenever we were doing the bolting, the placing of bolt and the placing of holes are very important. Okay, so if you are not calculating the moment of inertia exactly, if you are wrongly placing the holes, that is the bolts in that place, there will be the tearing of the bolts may be there. So it will lead to the failure of the structure also. So therefore in that part also the moment of inertia is playing vital role. And the designing of bridges. So nowadays due to the population, we are constructing bridges everywhere. Here also the moment of inertia is important, and also as I told already, the earthquake and the wind analysis also important, and also not only for superstructure, designing of the superstructure, but also for designing of the substructure, that is for foundation design also we are using these things. Okay, and so we will summarize the thing in this session. What we have is the first one, the parallel axis theorem. So it is nothing but the addition of moment of inertia about the center of gravity plus moment of the area into the distance, and it is used in the built up section, designing of built up sections, beams and columns and composite structure. And the perpendicular axis theorem states that the moment of inertia about any axis is nothing but the addition of moment of inertia about the another two axes which are mutually perpendicular to each other. So here the application is for torsion analysis and designing of slabs, plates, the bending behavior, and also for the calculation of the structures. So okay, here at finally in both the theorems are used in the designing, that is a structural designing. Mainly for structural designing we are using these both the theorems. So thank you for listening this video. Thank you.